Right. So when you have no, basically the way a here block works, it has a series of statements and then it has an optional expression.
Hmm.
And so when you have no semicolon, this is going to be the expression. And I think that's what we're looking at, though I might be looking at the wrong thing. But you see there's no statements and there is an
Right.
expression. And if you look only, well, maybe this is something else, because here's the expression is a block. It has no statements. Here it is. This is the real one. It's a block. It has no statements. It has a call as its tail expression. That's like the value of the block, right?
Hmm.
But if we put the semicolon in and we rerun that, and now what line were we on? Line 379. It's probably around the same spot. Let's see. What do we got here? Well, okay. Looks the same. Well, I don't know. There should be a statement that wraps it. I'm not sure why I'm not seeing that now. Am I looking at the right file? Yeah. Anyway, forget the here tree. It's kind of hard to read anyway. But the point is, it looks really different in the here. And if we just jump to the definition, I'll show you what I mean. Also, I just got a message. So yeah, so a block has a list of statements and then the expression at the end of the block without a semicolon, if any, and a statement can be one of these things, right? So now the question is, why are we getting this warning when we, let's see, yeah, right? And that's what we want to debug. So I was going to try to walk you through how I would debug this.
Yeah.
So we know that we're going in, what's the function called? Is it in write back?
Yeah.
Let's get rid of this. How do I make this thing go away? Go away.
Yeah, I think one more click. Yeah.
Okay. So we need like span lint or something. This is it, right? And we have these debugs. We actually don't, no, I don't, yeah, okay. So why don't we dump out the debug output, first of all. So, right, so this is my first go-to thing is dump out the debug output and try to get an idea. And I think, right, so the way that lints work these days, this wasn't always the case, they actually sort of dump right at the point where they get added most of the time. So we can kind of see the debug output that came right before, right?
Oh, I see.
And there's a few useful flags I'll just show you for. First one is treat error as bug. So what that does is anytime an error occurs, it aborts compilation.
Oh, okay.
And that's really useful because then you don't get all the junk afterwards, right?
Like
we know that something went wrong before this point, so we don't care about what comes after. And then I like to do -z verbose. What that does is, I'll show you, it's a subtle difference, but it basically converts the way we print types. Like here you see these underscores. They're type variables for inference.
I see, yeah.
And the problem is in error messages and stuff, we don't want to print like a bunch of debug information. But because we only really have one way to print types, this is sort of you have to pass this flag and that'll cause it to dump out like now I know the actual numbers of these variables, the internal identifiers. And sometimes you need that and sometimes you don't, but it just adds a lot more information into the printout. So now we have these two things we can look. And what we know is that the here ID, we know that this type was something from diverging fallback, and we know that the here ID is not present in the dead nodes set, right?
Right.
So the question is, what is this the here ID of? That's the first question. And it's local ID 9. And all this code has changed a lot since I last looked at it. But let's see. See if I can use my old tricks. It's kind of a pain in the neck sometimes to figure out what the here ID corresponds to, but there's a few ways you can do it. It would be nice if we had a better way. One thing which I will just do is we probably want to dump a little bit more debug logs. Step 1, because probably we're going to want to see something that comes outside of writeback. Right. But also that maybe that here tree tells us, actually, I just realized it might be in there. I'm not sure. Let's take a look. Yeah, what's this got? So like local ID 9.
Get unchecked.
This could be right. Bunch of stuff. So yes. So I think that, hold on a minute. Let's look at, so it looks like these are the fields of the blocked structure. Are you following, or am I going too fast?
No, yeah, I'm following.
So it looks like this is the here ID of the block itself.
Oh, okay.
And I think that makes sense, because what's happening, I think, so it's the here ID of this block. And the problem is that we never put blocks into the dead node set. If you remember, we added that code.
Then never.
We added the code, but what's the name of this file? Check mod, maybe?
Yeah, I think it was in mod.rs of type CK.
Something like that. There we go. Self.dead.
Dead underscore node.
Nodes. Why is it not finding it?
Oh.
Here, self.dead nodes. Oh, it's under expr. That's kind of the problem, actually, that I wanted to show you, but okay. So I think we added this code. There we go. Here, in this function check expr, basically. Check expr with expectation. And the problem is we need similar code in other places. Because this is only applying to expressions.
I see.
There are a couple other kinds of things with types that we would need to check. So either, well, we need to do one of two things. Either we need to suppress the lint unless it's an expression, or we need to add similar logic for blocks and maybe statements.
Okay. And that's the complete set?
Yeah, those are the only things. I think those are the only things where, I'm not actually sure about statements, if they have a type or not, but.
Yeah, means I guess we can figure out if we run into other.
I guess they shouldn't. Like, they're supposed to always be unit, so. But we'll see.
Yeah.
maybe we'll see, but blocks for sure have a type, because the block is.
Yeah, that makes sense.
The only question then is like where, we need a, let's see. Oh boy, that didn't work. What is it? Control T? Okay. I think there's just a function called check block. But is it this one? Check block no value, check block with expected. That kind of does the same thing as check expression. And you see it saves the diverges state and does a bunch of stuff, blah, 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 which hopefully doesn't return or anything, presumably not. Yeah. And then comes down here. And I would expect it, let's see. I guess we update self.diverges.
It's
Like,
always okay.
it's kind of getting updated as we go through this loop, I guess. Because in the expression code, there was this set call, that ORed in the old diverges.
Yeah, so there was a similar block, right? In the new file that you opened, which had that it is always that we check for in expr.rs.
Do you mean this one? Or do you mean up here?
Yeah, like, yeah, always, yeah. But it's not always.
So this
So
is,
maybe the else.
yeah, this is a bit different. This is doing some coercion logic. Some
I see.
logic that I'm just a little curious why. I guess, okay, so there's one, I don't know why this is different between statements and expressions. It's not important for our purposes. But you see that in a statement, it reads the value of diverges on entry.
Yeah.
But it never changes it. It just reads it. And that's fine. It doesn't have to change it. But there's, where's the code? Is this it? Check mod? No.
Check expression.
The expression. Yeah. This one. If you read this expression function, it replaces it with maybe. I'm not really sure why we hide it here and we don't hide it for statements. There's probably a reason. I don't think it really matters for our purposes right now, but it does explain why we have this or here.
Okay.
Because when you hide the old value, you have to bring it back in on the way back up the tree.
Okay, I see.
So, however, in the, where's the, and this one here, we just read it, we don't replace it. So then it stays what it was. And I think it can get, that basically on entry, if you remember, it's encoding if anything leading up to this point diverged, right?
Right.
So it stays that way. And it might get tighter as we go through. It might, like if you see a panic, it's going to change from maybe to always. And then the important point is here at the end, on the way, this is always true, on the way up the tree, it's set to whether anything diverged at all. And so we can say if self.diverges is always, you basically copy this logic, right? Now, I think we probably want to pull this into a function at some point. Just not because it's so much code, but so we have a place to put a comment and so forth.
Yeah, makes sense.
What is going on? But for now, let's try it and see what happens. And hope this actually, oh no, that's not it. Good. thought it was something about standard has. No, roast analyzer is running cargo check, I guess. What's this? If this works, do we have any examples? We know the examples we expect to get errors on. Or
Yeah,
warning.
yeah, I think there was just one example that we got from the issue comment that you actually created.
Yeah.
So we have that in that, and then the new example that we added last week. I guess you added last week. So those are the only two we have.
So I guess if this works, what we'll do is we'll turn back to deny by default. And then we can sort of run the test suite and do a crater run and see what comes out.
Makes sense.
Deny by default is good for crater because you still get errors. So you see what broke, or like you see what code is affected. However, you also, those errors are suppressed if they occur in a dependency.
Oh, okay.
Which means that's good because otherwise, like if some crate that everybody depends on is broken, then it looks as if 10 million bits of code are broken, but actually, you see what I mean?
Right. I see.
So using lints is pretty useful for that. Let's see, let's run this, but let's not. Ugh. One thing I really don't like about VS Code is that the shortcuts I'm accustomed to in the shell do not work. Which is annoying. So we don't get it. Huzzah!
Function is never okay.
So
is it different?
That's good, right? We did not want a warning here. Now the question is, will we get a warning if which is the one where we do want a warning, I guess.
Yeah, it's in the same. Yeah, never type lint. I think the one below. Yeah, that guy.
We probably have to turn on the. Yay, we do get an error. Okay. We get kind of a lot of errors. We probably want to suppress that a little bit.
Okay.
I think what we can do, these are all from the same. Well, actually, let's do a check. Like, I think these are gonna, what I think is these are all probably related to the same type variable.
I see.
And so we could have a little set that we keep where we say, if we've seen an error related to this type variable before, like don't report it again.
I see.
The only thing would be, my only hesitation here is that I think that would be fine, except if you look at the order in which it occurred. The first one we got was this really far out one. The next one was more local. And then we got this crazy one over here. They all make sense, but probably the best one is this one, right? This is like
the innermost.
Yeah, which I don't know. I don't know how hard to work at this, but it'd be nice if we could give that one. I guess one thing we could do is track spans, and like if we really wanted to work at it, we would collect the spans and find the spans that overlap or something and pick the smallest one. I don't know. That seems a little too insane, or that seems like we're working too hard.
It's also like that the one that we want, it came in the middle. It wasn't the top, or
Right.
I don't know how it unrolls.
Yeah, it's just dependent on what order we visit things in, basically. We visit
Ah,
them.
okay.
We probably could change that so that we visit it more inside out than outside in, but I don't know. That might have other side effects. I don't know.
Mm-hmm.
I can't imagine what they would be, but it doesn't. Hopefully, people are not getting this error a lot, right? So, like, if they are, that's a problem of itself, of its own. So I'm kind of inclined not to. I'm kind of not optimize that stuff until we know. But I wanted to see, so somewhere here, okay, right. Oh, this is useless. So what I was hoping with this debug output is we can see the n-tie original value and just get a sense of, it's not, why? Refresh. I don't know why. I'm confused.
Oh, the inference variables are not. Maybe you can give a different file name.
There we go. I don't
Okay.
know. Okay, so this one is 2. Oh, they're not all the same variable. This one is 3. That one is 0. So never mind. My heuristic wouldn't work anyway. Oh, I think I know why that is actually. So, no, actually I don't know. I think you, okay. I think what's happening here, actually, I do, is that this n-tie original is the original inference variable. If we resolved it, yeah, it's kind of a pain. I think we would find that it's unified with, we could probably figure this out. We would find that it's unified with the variable that fell back to not never, but that state isn't really exposed to us very easily now that I think about it. So, all right. So short version is suppressing these lenses, these duplicates is going to be a pain in the neck, but if we care to do it, and hopefully we just don't have to. I think one thing we could do, the absolutely simplest suppression would be to say just report 1 per function.
Ah, I see.
Or something like that, or like 1 per statement. That's
Yeah.
probably good enough. Anyway, this is good. We fixed the bug. What is this foo? I don't know, but this is where we made the change. So I think the next steps after this, we can chat about it, or we can note them down on Zulip, but I think it's basically, we should clean up let's make a little list.
Yeah.
I'll dump it on Zulip later. I think we should clean up the, or create a helper function for adding to dead nodes that explains what is going on. In particular, I would want to document that this function is invoked on the way up the tree, so that nodes are added to dead nodes set if they diverge before completing. Or they never start, which is the same thing, actually. Make sense?
Yeah, makes sense.
And then next, we would want to, and maybe before that even, turn the lint to deny by default and make sure standard builds. We'll do that right now. Where is this lint? What is it called again?
Never type. Yeah.
Fallback might be one word, but I don't know.
Yeah, yeah, you're right.
See what happens. Hopefully that works. And then we want to, we probably should improve the error message, which is not so great. But let's put that as 4, because 3 is we probably want to run a greater run. There is one thing I would also add that we could do is there was an original crate that caused a problem in the first place. I think it was the Objective-C crate.
Objective-C.
And that's how I extracted that test case, but we ought to go back and check that the original also gets a warning, or else, you know, maybe I missed some detail.
Okay. Yeah.
But that can come relative. Yeah, we should probably do that, like, or during the creator check.
Yeah, can happen parallelly.
If it turns out we're not detecting the pattern we want to detect, then the creator run is kind of not that interesting. And then I think
it's a multi-day run, right? The creator one.
Well, sometimes, yeah. The creator check runs are much faster, but there is often a queue.
Okay.
I don't actually know how long they take, but the creator check are like significantly faster than a full creator run, maybe like 10x faster or something, maybe more.
Okay.
Because they don't have to actually run tests or anything; they just do a cargo check.
Oh, okay, makes sense.
But there's often a queue, and that's the problem. So far, so good. It looks like we built standard, or at least we built core rather. Okay, this is cool, and then maybe we're done.
Nice. So this is like if we run creator and we don't see like any major issue, then that is the end of it. We don't
Well,
just the lint is good enough, right? You think?
I think, yeah, if we don't see any major issues and we found the one we know of, then
Nice. Built successfully.
great. Okay, that's great. Then we should be able to have to kind of page back in. Is this the only thing we were blocked on? Probably. Then I think what we want to do, we probably want to land this lint. We'll have to figure out exactly the ordering, but I suspect we actually want to land the lint even if we didn't, like the lint is called fallback to never type, and we might want to rename it. But the truth is that even if we never changed the fallback, even if it still fell back to unit type, it's probably worth linting code that relies on the fallback period. Because it's not meant to affect live code. It's meant to affect dead code only. So I think we could land this lint as a first pass, just saying like, you should really add some explicit type hint, especially if it doesn't seem to affect a lot of code. And then we can separately do the fallback, you know.
Okay. Separately do the fallback means enable the feature, because this was a blocking.
I meant to stabilize the feature basically.
Oh, okay, yeah.
Fallback for everybody. But the idea would be, I think it would be nice to have this lint out there for at least a cycle or two. We'll have to talk about it with the like release team and how best to manage it. But ideally, we could issue this lint as a future compatibility warning, for example. It's not perfect, but it's kind of covering what we consider to be the worst cases where we expect to change this, and so you get a warning that it's going to change, and if you want it to stay, you should add some explicit type annotations.
Yeah, that sounds reasonable.
All right, great, and I'll see you next week. I'll post this list in Zulip, and well, I guess we did number 1, but maybe we'll post it on the issue. I don't know. Post it somewhere.
Yeah. Yeah.
If you need help with this step of testing against the crate, I can point you at the GitHub issue where the author of the crate was. I bet they could supply you a test case or something.
Oh yeah, sounds good.
Okay. Yeah.
You will push the changes, right, to the.
Yeah. Did I not already do that? I'll push the standard changes at least.
Yeah, I think you did the commit, but I don't know if it pushes that also upstream.
No, you're right. I don't think it did. I should add this. Cool.
Awesome. Thank you so much.